last summer at ESAC. And then I know that it was improved in conversation with Neil, between Neil and Georg Haig and James Foster as well, so thanks for their contributions. So did, most of you I'm sure saw Arden and Dirk present Building a Business with ObjectStudio today. Did everybody see that? Anybody that didn't raise your hand, I think I'll have to leave because that was a prerequisite. No, you're late flight, Martin. We'll let you off the hook. Jim, on the other hand, has got to go. So they did a great job showing how to use Cincom ObjectStudio to create a new application. What we want to do is today is show you how to use those same tools to support a very different development scenario. One where you've got legacy applications that you need to keep running, but you need to create new functionality somehow as well. So what we'll do is we'll create a new web application that provides the new functionality, but still allowing legacy applications to keep running as they always have. Good. Yeah. So this is our problem: how to support change and keep the legacy alive. Those legacy apps, they're still doing their original job, and they have to keep doing it. It's important stuff. But at the same time, they're kind of brittle, a little difficult to change. Maybe they were actually created by contractors who were subcontracted out to do it, and that company is gone. And I heard that David support knows something about this. We've probably all seen that kind of scenario. So what we want to do is add some vital new functionality to it, some new requirements, maybe just do business process, how to do things better, maybe government regulations are coming in and forcing our hands. So this could be a recipe for some trouble, but we want to show you that I guess our big point here is that some development tools are great for kind of ground up new application development, but this kind of scenario where you don't have that option is a situation where Smalltalk and where ObjectStudio, the mapping tool in particular, can really shine. Can help you kind of push back what is possible to accomplish. So our domain, for our example, is medical diagnostics. So Neil Ross is the expert in this. So I'll be probably skipping through some of the details here. But blood cancer diagnosis involves doing testing work with multiple labs: genetics lab, immunophenotyping, hematology for the blood work, and histopathology, and maybe some more as well. And Neil likes to liken the process to an episode of the medical TV show House. Has anyone ever seen an episode of House? All right. James, maybe you can come up and present this slide for me. Well, so it goes a little something like this. It starts with a patient comes in with some symptoms, and it starts with a diagnosis. And now there's nothing to worry about. He just has a mild case of polysyllabic medical term, and we will take care of that without any trouble. But then, of course, as the episode goes on, I don't understand it. All our tests are coming back negative. The fever's getting worse. What are we going to do? So they phone the lab and request additional testing. And in the lab, it's panic because we've got to find a sample to be able to do this testing. In the end, everything works out, and it's another life saved by the diagnostic skills of Dr. House. But, of course, the writers on House don't have to worry about tracking samples from place to place and making sure everyone knows what is happening. So that's the real-world job that we're trying to help with there. Yeah, this comes from a real domain where, this is some work, as I said, that Neil does, and kind of an opportunity for doing something better that he spotted and knew that Smalltalk was a fit for it. And remember, each of these labs has their own legacy system. They've all got a way of doing things, and that has to keep going. We can't interrupt that process at all. So that stuff will remain untouched. And we will do our work kind of built on top of that. And there are other complications, really in the real world, it happens that some of this work was subcontracted out. One of the labs databases was subcontracted out to Romania, and Romanians. So the names just might not make sense. The table and column names sometimes aren't what you want for your domain. So the example storyboard is that the pathology lab gets these samples, prints labels, sends them off. In the genetics lab, sometimes you just have a problem of wasting time. And maybe they realize they think that the problem is just anemia, and they could skip their test because the blood work will tell. But they can't get blood work on the blood lab on the line to find out, so they've got to go ahead and do their thing. Or it can be worse. Sometimes, as the diagnosis evolves, you've got to send samples, move them from one place to another so you can do the proper testing on them. And if no one knows where the samples were sent, or it's difficult to find out, it's an opportunity for improvement, where in a case where time is of the essence. So we need some kind of system to track all of this, and we have to create it, as I said, without interrupting the workings of existing things. Wouldn't it be great if we had a web app that would let the pathology lab enter the sample data into the database, put in a data dispatch when it was sent off to the other databases, so everyone has a view of the same information. We could avoid the time wasting situation, and even better, provide better performance in the life critical situations. So what we want to do is create a web app for this. And all we want is to be able to read and write data to these legacy databases. And on top of that, we want a new class model in Smalltalk that makes sense for the domain and that provides all the functionality that we need. And to map that to a schema for a new database that will be the combination of all of them. And each one of these steps, I don't know, it doesn't sound too hard, every little step maybe, and especially if you're working in a well-funded environment with lots of time to do it, but in fact, getting it done in the real world can be not such an easy task. So, is it possible? What do you think? Can we do it?
Yes.
As long as nothing goes wrong with our carefully scripted demo, we can. So what we're going to do is we're going to read the schema from the old database. We're going to generate an object model from that and map it to the database using Glorp. We'll evolve that object model to make it make more sense and and provide more functionality. But while we're doing that, we're going to keep it mapped to the genetics database, the original genetics lab database. And by the way, there's a similar process with all the other labs. We'll just kind of show one as an example here. And finally, we'll create a common new database for the web application. So I'd like to bring up my lovely assistant, Andreas, to make it all happen here. So he'll connect to the genetics lab database. Are we visible? Yes. He'll connect to the genetics lab database, use the mapping tool to generate a class model and a Glorp descriptor to map them together. And we'll start with that.
All right, whatever you said. You probably saw the mapping tool that first time when Derek and Arden presented yesterday. So that's just the user interface for the mapping tool that we have for ObjectStudio. First, I have to create an address. OSD 2012. We're using the active record pattern here. It doesn't mean we actually use the whole active record framework. Connected to a database, we have a local Postgres database here. I just need to connect to it. And put a typo. Postgres, I probably want to save it. Let's connect there. Thank you very much. The tables are in the public schema, and I'm just going to get all the tables from the existing database sucked right in. This is a subset of the original database just for testing, so this time I can just get all the tables, select, and we have the tables with the primary key and foreign key relationships right here. Now we use pattern matching an active pattern, active record pattern here to generate the clauses. And we go into the package called stick 2012. And boom, we have the clauses. And right now, I can show you that we have the patients right here. First of all, down here you see the mappings, those direct mappings of the table patient. And we actually have a little bit of data in here. So we have 4 rows, and the first one is historically poor, epiphenomia, and so on.
Anonymized data, you'll want to be the same, I think.
Yeah, you won't find those people in the real world. The patient, if I just inspect the class, we get instances of the class patients, and the first one here is my Dorothy Moore again. So we already have the live connection to the database. We can create objects, we can create instances of those data, and have them mapped out.
All right, good. So if you could see the names and so on up there, you might have noticed some of the problems with them. So the schema has patients going to RAS sites instead of to hospitals. The patients are seen by RAS client contacts. The strangest one of all, I think, is folders. What that actually means is sample. That's why they track the samples provided by patients. So we kind of assume that whoever created this kind of reused some work they'd done for some other domain or something. So it's tough to work with. So what we'll do though is we'll start manipulating the object model to make it make more sense and something that we can work with more easily.
All right. So the first thing that we rename is our class folders. We just rename it to the samples. Hit rename. Yes, we want to do that. And the rest client contact we want to rename into the consultants.
We're actually going to evolve the consultants a little bit further in shortly.
Now, I'll write the descriptor system again. And, never mind. The modeling tool is something that we now could use, or can use, to evolve our model. It's just something that we can use here. So create submodel, and that's something that we want to show you. We are not just a top-down product here, but we can also synchronize the code from or synchronize the model from the existing code base. As soon as I find my stick control, there we go. Select my classes, and then we will synchronize. Now we have all the classes right here.
So in this case, we're not really using the modeling tool very directly. I think that we probably would if we started getting into the scenario where we're adding in other legacy databases and finding the common points. All these lab systems do something relatively similar. They take in samples, they identify them with patients, they provide diagnoses or test results. But so it's so we won't do too much with the modeling tool, but we certainly could as we went forward with this. We'll just show you that you can see, and that if we so I don't think we need to show everything, but if we come into it from a different way, we could you could see the relationships. It's just an aid in seeing what the schema looks like in a graphical way. It's an aid for the developers and also for developers explaining what things are what they're doing to their management.
Yeah. So, for example, we could put in some new clauses in here, make them subclasses actually from here to here and things like that. So in order to evolve that, you talk to your customer, in this case, you talk to your client, show him again, this is the database that we are talking about. These are the classes that got generated from the database, so we have access to your data. Is that exactly what you want? We wouldn't know that folders automatically match samples. But after carefully selecting or reviewing the data that was in the database, in those tables, you actually got the conclusion that, okay, these are the samples that you have here. So I'm not going to change the model. Okay.
So good. Well, so step 2 is another manipulation we're going to perform on our object model is to specialize. So the consultants is a good start, but really what they have, the way it works with the lab is they're referring consultants. These are guys who just take in the patients and send the samples off to the lab, order certain tests. And then there are diagnosing consultants that get, and these are guys when the diagnosis gets more complex, these are the guys that head up a team of specialists from different areas, and they take in the results and review and suggest treatment. So there are different roles, different, they come in at different points in the process, and data has to reflect that. So Andreas will split referring consultants into both referring and diagnosing consultants.
So, yep. Those refactoring steps, you can watch them if you want offline, but we're not going to run the scripts, we're not going to do refactoring right now here, because that's awful no typing. So we are using the generics atlas that we've provided before, and connect to the same database. Now what we have here is consultants, diagnosing consultants, and referring consultants. All of them are actually mapped to the same database, I have to say to the same table. The referring consultants is mapped to REST client contacts, diagnosing consultants, and consultants is there as well. What we have here in Glorp is this thing that's called resolver, and we have a type mapping here, which means, I don't know if you can really read it, I hope so. The choice is made by checking the role column in the table REST client context. If there is a content called referring, then we get a referring consultant. If we have a diagnosing consultant, then in this column is the word diagnosing right there. And we have those two are subclasses, so the old business logic can be the same as much as they are in common, but the tool itself splits it up into the two different subclasses. So when I go back to my consultants here and say inspect, I'm getting the referring consultant, another referring consultant, and I get the two diagnosing consultants. And just to make sure that this is the right thing, we have Dr. Chris Robertson, and the role is referring, and it's a referring consultant object. In here, we have a diagnosing consultant, Dr. Jenny Bond, and the role is diagnosing. So the tool itself, the framework itself, makes a distinction for you so that you don't have to.
So now let's create an atlas in the mapping tool for our new, we'll call it the referral DB. This is the web app DB, the kind of one database to bind them all, the one that we use for our new stuff. This descriptor, it'll map the same object model to that works with the genetics DB, but map it to a different database schema. And the table names this time will be driven by the object model, so they'll make a little more sense, be a little easier to work with. And in this case, we'll have separate tables for diagnosing and referring, for instance. Again, we won't show every step here, but there are different ways possible ways of creating this, the new descriptor. You could subclass the old one and do a refactoring on that, or just generate from the mapping tool.
So what we have here, what Mark was talking about, is called here the referral address, and now I have to connect to a different database. It's also Postgres. Let me save that as TV. So the tables that you see here are not yet in the database. So what I can show you, the PGAdmin, that's really quick.
So the atlas in the mapping tool is kind of the meta information that it will generate the Glorp descriptor, so it just has the information about what the object model looks like, and in this case, what it generated a database, a schema that will map to that model.
Yeah. So tables is 0 here, so we do not have any tables so far.
And one other piece of functionality that we'll do, we're adding a new instance variable. Data dispatch, we kind of talked about what the business case was. Given this, the labs can communicate, the hospital can communicate with the labs can know what's coming, know what to expect and prepare for it. And we probably have that mapped in.
We have
in our referral.
We have that all mapped in the new database. I just jumped back to my old address and wanted to show you that in samples we indeed have a date of dispatch instance variable, but it's not mapped at all. So it does not get read from the database or inserted into the database. It's just basically ignored. So we have to we have left out this mapping because the old database doesn't know about this data type, doesn't know about this column, but the new one needs it. So when I switch over to my referral, my date of dispatch here is mapped to the samples table that we're going to create.
Good. So now, finally, with all the changes that we've made to the model and the descriptor for it, we'll create the schema in the new, actually create the tables in the new database. And create, yeah, please go ahead. So this to me is kind of where all the magic happens. We've got this single object model. It is mapped to existing databases that have to be left alone. But now we've got these same objects mapped to a new database that we can change and evolve to do what we need to do in the future, supporting the new functionality.
And as you can see here in PGAdmin, we have now those tables, as we said, with the diagnosing consultants and the referring consultants. And if you check the properties, we have the columns, and we have those constraints already generated for us, just like it was in the database before, and for the new tables as we defined it in the mapping tool here. So.
And data? Are we going to do data too?
Absolutely.
All right.
Last but not least, we're going to do the data too, and I probably want to show it a little bit bigger. Let me just note that.
So I have to admit, Dirk warned me about this one. So what the script is doing is reading data from the old database, using the old descriptor, and then switching to the descriptor from the new database and just saving it. And this save is like super powerful and sometimes dangerous thing. It's gonna just say which objects are we actually using? Orders. Yeah, so it's gonna take the orders and save them. But what that means is the save fans out through all the relationships to all the other associated objects.
So what we do here basically is just we we create a platform, okay, we want to connect to Postgres, we create a login. Finally, we create a session that with this login, and here we create just a new order, a new instance of type order, and say find. And find in here, since order doesn't contain any fields, says okay, I'll give you every order that is in the system, and I can inspect the collection. Now for the new database, I pretty much do the same thing. I create the section, I log into the section, and I just tell this collection, iterate, basically save each member that is in this collection here. Now, as Mark said, the data that we read from the database is not just the data from one single table, but since we have the relationships mapped here, every child, every additional data from additional tables gets read too and subsequently saved into the new tables as well. Which means that with this little script here, I can get all the orders, all the patients, and all the hotels and hospitals, and all the doctors in one big step. So, I'm going to minimize that. I'm just going to run it. So what we get in the time in between is a virtual collection of orders that is a proxy for the in Glorp here. We have the real objects and there are orders. And if I check an order, it has a folder, which is the samples. It has order number, reporting date, priority, and the group, course per session, and on and on. I could go into the folder chart, the value, date of dispatch, my patient, here's the patient object, and the patient identifier, and so forth. So what we did here with this is go view. Now we have those diagnostic consultants here because we split up the data between two different tables, and in here we get the diagnostic consultants, and the other one we get the referring consultants. But at the same time we get the orders that we started from in the beginning. We have patients, and we have our samples down here. And everything was basically done just with this find and with this save to go from one database to the other.
So that means we did it. The magic happened. Good. Well, obviously, it's a lot to show from a real domain, and so we had to, didn't show every little programming step in between. But hopefully, you got a sense of what's possible to accomplish. Any questions from anybody?
Do saves happen in one big transaction, or each save the orders one by one?
Yeah, how does that work transaction-wise when you do the global save?
No.
Yeah, the question was, is the entire save done in one transaction, or how is it broken up? Is that right?
In this case, the save is done by order, by the order object. So each order object does a begin unit of work and saves it out, spreads it out to insert all the data that is necessary that it can reach in this case. When it returns afterwards, it doesn't commit. So even if you interrupt the save here, the ones that got actually written, they are written, so they're not rolled back. If you want to do that in one single huge transaction, you actually have to start a transaction before that, do the save, and then do a commit afterwards.
All right. Anything else, Mary?
So this tool is not just for ObjectStudio, as we said, it's for a web application database, and it's for Glorp. So the whole purpose, oops, not this one, the whole purpose of the mapping tool that we are having here is really to make this easier for everybody to access any kind of database. Whatever database is out there, we want to, and you need to access it. Is it SQL Server? Is it Oracle? Is it Postgres like we have here? We give you the tables, we give you the relationships inside those tables. You can generate your object out of it, meaning that most of the work is already done by the time when you click on write the descriptor system. Each object knows how to save itself, each object knows how to find itself. You can write like you did with playing Smalltalk. You can do a collect statement, you can detect statement, you can do all the Smalltalk things that you like, but you get to work with the database instantly. You just don't realize it anymore that you are working with data and database because you have to draw framework in between. So that made it so easy for us to actually say, if I want to have a special order, I could have typed in set my ID to something, and the find would not return a collection but a single object. In my case, I said, give me every order because I know there are just a couple of orders in my system here. Then afterwards, you can still do a save into a new session, into a new database. So the update, again, is pretty much transparent to you. You just tell it to save, and it does it. Where does it do it? You specify during the session. So the object doesn't, but the object doesn't have to originate from the session. So it can be a collection of various objects coming from various sessions and going into one single database. So that's what we say with the magic here. If you look at the strip, I would say 90% of the code here has to do with login and the session itself, and just basically 2 lines of code, the find and the do with the save here actually make magic happen and save it to the database.
And just to, lastly, just to repeat that, the mapping tool is an ObjectStudio tool. It runs on Windows only, but it generates Glorp descriptors, and those descriptors can be used in any visual system on any platform. So the mapping tool is a one-time thing, then at runtime it's Glorp that's making it all happen. Yes, well,
If you run the find twice, will you get copies?
Will you repeat that?
yeah, if you run the find twice, will you get copies? And it should be doing caching to get the same objects for the same database rows, right? Yeah.
It's the same object, yeah.
Was that what you meant? Do you get multiple copies for the same object, right? Yeah, no, so Glorp is doing the caching to get the right object identity, right? Thank you all very much for coming.